Welcome to week 3. We are ready to dive into quantitative research this week. Before that, we will learn major sampling strategies that are applicable to different research methods. This part is not covered in the textbook. Please refer to the course slides and the supplemental materials. Here is the outline of this week's learning content. We have a lot to cover. I hope you are ready to begin. Let's start with sampling strategies. In educational research, we often collect data from people, but the population we are interested in can be very large. Because of time, access, and resource limitations, researchers need a plan for selecting participants. A population refers to the larger group of individuals, cases, or settings that a study aims to understand. Although we may be interested in a large population, it is usually not realistic to include everyone in one study. The number of people who can be included in a single study is usually limited. Researchers often narrow the focus to the people they can realistically reach. The question is, how do we move from the larger population to the specific people included in our study? This process is called sampling. Sampling is the process of selecting a smaller group of participants from a larger population to take part in a study. Let's introduce two relevant concepts related to population. Target population refers to the broad group of people, cases, or settings that researchers ultimately want to understand. However, researchers often cannot reach every member of the target population due to limits in time, funding, access, or location. Therefore, they usually narrow the focus to an accessible population, which is the portion of the target population that researchers can realistically reach. From this accessible population, researchers select a sample to be included in the study. The target population is the broad group researchers want to understand. The accessible population is the portion researchers can realistically reach. A sample is the smaller group. Sampling is necessary because, again, it is often not possible to study an entire population, especially when it is large or difficult to access. By selecting a sample, researchers can collect data more efficiently and reduce the time and cost involved. A natural follow-up question is whether we can still generalize findings from a sample to a larger population. With this question in mind, let's discuss a key concept in sampling. In general, researchers want a sample that represents the larger population, especially when they hope to generalize their findings. However, when generalization is not the main goal, such as in some action research projects, representativeness may be less central. There are two major types of sampling methods. Probability sampling uses random selection and supports representativeness. Non-probability sampling uses non-random selection based on convenience, access, or other criteria. We will first discuss probability-based sampling strategies. These approaches involve some form of random selection. Simple random sampling means every member of the population has an equal chance of being selected. Researchers may use a random number generator to select participants. Suppose a researcher wants to study Facebook use among 500 students at a local high school. Each student is assigned a number from 1 to 500, and the random number generator selects 50 students. This process gives every student an equal chance of being included in the sample. Systematic random sampling selects individuals at regular intervals after choosing a random starting point. For example, if the population includes 5,000 college students and we need 500 participants, we could select every 10 students after identifying a random starting point. Stratified random sampling divides the population into subgroups or strata based on characteristics such as gender, grade level, or program type. For example, if 75% of K-12 teachers in the state are female and 25% are male, the sample can be selected to reflect that same gender distribution. Cluster random sampling involves randomly selecting groups or clusters rather than selecting individuals directly. For example, if we study middle school students across a state, we may randomly select several districts first and then select students within the selected districts. Now we move to non-probability sampling. In this type of sampling, participants are not randomly selected, so generalizing findings to the larger population is more limited. Convenience sampling includes participants who are easiest to access. It is simple and inexpensive, but we usually cannot know whether the sample represents the larger population. For example, if you study undergraduate students' online learning experiences and only survey students in your own courses, the sample is convenient, but may not represent all undergraduate students at the institution. Purposive sampling uses researcher judgment to select participants who fit the purpose of the study. For example, if the study focuses on international students' experiences using English learning apps, the researcher would intentionally recruit international students who have relevant experience. Snowball sampling recruits participants through referrals from other participants. This approach can be useful when the target population is difficult to identify or reach. For example, if researchers study school connectedness among students with disabilities, initial participants may help identify other students who meet the study criteria. Quota sampling divides the population into subgroups and then selects a set number of participants from each group. For example, if a study examines teachers' use of digital tools, the researcher may recruit a fixed number of teachers from different subject areas. Here is a quick recap of the sampling strategies we discussed. Probability sampling includes simple random, systematic random, stratified random, and cluster random sampling. Non-probability sampling includes convenience, purposive, snowball, and quota sampling. When reporting sampling procedures, explain and justify the sampling choice. Identify limitations when needed and report all available information clearly. The sampling strategies are generally applicable to both quantitative and qualitative research. Here are the references for sampling methods. Check the supplemental reading based on your interest. Let's continue with quantitative research. We have covered the basics of quantitative research in Module 1. Quantitative research is a type of social research that uses numbers and statistical analysis to study relationships between variables. Its goal is usually to use data from a sample to make broader conclusions about a larger population. Hope you know what this means after we cover sampling. I want to point out that non-probability-based sampling is commonly used in quantitative research as well. We will discuss different types of quantitative later this week, while we will cover qualitative research in modules 5 and 6. Let's quickly refresh our memory of the key differences between quantitative and qualitative research. It makes sense to learn them together to understand the key differences between two research approaches. Quantitative and qualitative research differ in method and focus. Quantitative is usually more structured and focused on numbers using different types of measures, while qualitative focuses more on people's experiences, meanings, and interpretations. The textbook presents two central questions for our consideration: whether objective truth exists and whether it can be known, and how people come to know truth. It distinguishes between big truth, which assumes an objective reality exists independently of people, and small truth, which views truth as constructed through human experience and interpretation. The example of car accident illustrates this distinction. While perspectives on events may differ, conclusions can be strengthened through the examination of physical evidence, witness accounts, and the careful weighing of multiple sources of information. This section in the chapter explains the philosophical assumptions behind research, especially ideas about truth and how we come to know it. It introduces positivism and post-positivism, which both assume that an objective reality exists, but they differ in how certain we can be about fully knowing it. Positivism sees truth as discoverable through scientific methods, while post-positivism argues that truth exists, but our understanding of it is always limited and open to revision. In contrast, a paradigm like constructivism holds that truth is socially constructed and shaped by people's experiences, meanings, and interactions, used more with qualitative research. These perspectives help explain why quantitative research emphasizes measurement, evidence, and systematic methods. Quantitative research usually relies on deductive reasoning, which means starting with a broad theory or general idea and then testing it with specific data. As shown in this brief example, in social research, this often means beginning with a theory, developing a hypothesis, collecting data, and then analyzing whether the findings support that hypothesis. Quantitative research is strong because it produces reliable, objective results that can be replicated using standardized tools and statistical analysis. It also allows for generalization to larger populations due to larger sample sizes and helps reduce bias by relying on numerical data. Overall, it supports precise measurement, hypothesis testing, and understanding relationships and cause and effect, which advances scientific knowledge. All of these strengths rely on a high-quality research process. Quantitative research also has limitations because it can miss the complexity and context of real-world social issues by relying on fixed measurements and standardized methods. It may oversimplify experiences, and statistical significance does not always reflect real-world importance. Because of this, it may not fully capture emotions, perceptions, or individual differences the way qualitative research can. To address limitations in quantitative research and make sure its strengths are realized, researchers need to carefully design their studies by choosing appropriate variables, samples, and statistical methods that match the research question. It is also important to ensure validity, reliability, and ethical practices like informed consent, confidentiality, and transparent reporting to produce credible findings. A healthy skepticism is important when reading quantitative research because even strong-looking statistical findings can be misleading or misused. Issues like fake or manipulated data, p-hacking, and the reproducibility crisis raise concerns about whether some published results are truly reliable or repeatable. On top of that, research can be misinterpreted or oversimplified, especially when people confuse correlation with causation or struggle to understand complex statistics. For these reasons, readers should critically evaluate quantitative findings rather than accept them at face value. We will address some of the major concerns below. Increasing pressure to publish research can create incentives for unethical practices, including data fabrication and manipulation. Examples include manually creating data, altering results, or using AI-generated responses. Although data transparency initiatives encourage researchers to share raw data, the text suggests that completely fabricated datasets may be difficult to detect. As a result, concerns about data authenticity remain an important issue in research. Publication in a prestigious journal does not guarantee that a study is free from errors or research integrity concerns. For example, Nature has issued editorial expressions of concern regarding multiple previously published papers. You may search online if you want to learn more about the concerns. P-values are used to determine statistical significance, with 0.05 often serving as the threshold. The text introduces p-hacking as the practice of manipulating data analysis to make non-significant results appear significant. The author warns that these statistically significant findings may not represent genuine relationships and could lead to misleading conclusions. The reproducibility crisis refers to concerns that many published research findings cannot be reliably reproduced. Ioannidis argued that biases within the research process may contribute to false findings. And later, replication efforts by the Center for Open Science found that many published studies did not produce the same results when repeated. These findings have raised questions about the reliability and generalizability of quantitative research. Please check a recent article on the topic based on your interest. Quantitative research can be difficult for practitioners to understand because of its technical language and complex statistical tables. When findings are not clearly explained, research becomes less useful to those who could apply it in practice. Clear explanations of statistics and symbols can improve practitioner engagement. Finally, research results are often misunderstood or misused. Correlation means two variables are related in some way, while causation means one variable actually causes a change in another. A key point is that correlation does not imply causation, even though it is easy to assume it does when a relationship is observed. In quantitative social research, correlations are common, but proving true cause and effect is much more difficult because it requires strict control of variables and is often harder to achieve outside of experimental settings. We will address more of that when we learn different types of quantitative research design. Spurious correlations happen when two variables appear to be related statistically, but in reality there is no meaningful relationship between them. This can be misleading because it is easy to assume that any correlation reflects a real connection, even though it may just be random chance or coincidence. As a result, some findings in quantitative research may be false positives, especially when many variables are tested and only the interesting correlations are reported. Please check the video on the same topic based on your interest. Let's continue our discussion of quantitative research. Quantitative research is valuable because it uses numerical data to uncover patterns, test theories, and make predictions with a high level of objectivity and precision. It is especially useful for studying large populations, comparing groups, and identifying cause and effect relationships through structured and repeatable methods. However, while it is powerful for generalization and decision-making, it does not always explain the why behind findings. This is why it is often strengthened when combined with qualitative approaches. This chapter explores the main types of quantitative research designs and how each one is used to study relationships between variables in different ways. A variable is a characteristic of a research unit, such as a person, school, classroom, or organization that can take different values. For example, students may differ in age, gender, achievement, motivation, or learning engagement. An independent variable is used to explain, predict, or compare differences in another variable. It may be manipulated, such as a teaching method introduced by the researcher, or it may be an existing characteristic, such as gender or program type. The dependent variable is the outcome being examined, for example, in a study comparing achievement across online and in-person courses. Course format is the independent variable and achievement is the dependent variable. However, not every study classifies variables as independent and dependent. There are other types of variables, and we will not cover them due to the scope of the course. Quantitative research includes several common designs that are chosen based on the purpose of the study, such as describing patterns, explaining attitudes, examining relationships, or testing effects. These designs help researchers structure studies in different ways, depending on what they are trying to understand. A key feature of quantitative designs is the specific language and terminology used to clearly define variables and research methods. Researchers may not always explicitly name the research design in a research paper. We will focus on these 4 design terms when completing assignments. Correlational research design examines the relationship between 2 or more variables to see whether they are related, but it does not show cause and effect. It focuses on the direction positive or negative and the strength of the relationship, often using statistical tests to measure this connection. While it cannot prove causation, it can help identify patterns and even support predictions when strong relationships are found. This example illustrates a correlational research design. The purpose is to examine whether students' sleep quality is related to their academic achievement. Sleep quality could be measured using a survey or an established scale, while academic achievement could be measured using students' grades or other official records. The analysis would focus on the direction and strength of the relationship. For example, a positive correlation would indicate that students with better sleep quality also tend to have higher academic achievement. Experimental research design tests cause and effect relationships by manipulating an independent variable while controlling other factors that could influence the outcome. It typically uses random assignment and control versus experimental groups to determine whether a treatment or intervention causes a significant change in the dependent variable. This design is considered the most rigorous because it allows researchers to directly test the impact of one variable on another. There are different types of experimental designs available in practice. Please review the supplemental reading as needed. This example examines whether a flipped classroom improves student learning. In a true experiment, students are randomly assigned to traditional and flipped classroom groups, and their outcomes are compared. A simpler pre-experimental design measures one group before and after the flipped classroom intervention, but it provides weaker evidence of causation. Quasi-experimental research is similar to experimental research but does not use random assignment, instead relying on pre-existing groups or natural settings. Because of this, it can still examine the effects of an intervention, but it has more limitations in establishing certainty about cause and effect relationships. We can use the same example proposed for the experimental design. The key difference is that the traditional instruction and flipped instruction groups are formed without random assignment. Causal comparative research examines differences that already exist between naturally occurring groups. Researchers do not manipulate variables or randomly assign participants. Instead, they compare groups based on existing characteristics, such as gender, ethnicity, or prior educational experiences. Because the groups already exist, the design can identify differences but cannot establish causation. This example compares after-school learning engagement between male and female students. Because gender is a naturally occurring characteristic, researchers do not manipulate the grouping variable or randomly assign students. Let's quickly review other design terms mentioned in the textbook. Descriptive research design focuses on describing characteristics of key variables. It often uses tools like surveys and Likert scales to collect numerical data to summarize responses. The goal is to organize and present data in a way that shows patterns. Most of the time, a research study starts from describing the characteristics before they move to the 4 designs we described above. Longitudinal research examines how individuals or groups change over time. By collecting data at multiple points, researchers can identify patterns, trends, and long-term developments that would not be visible in a single study. The research designs are not mutually exclusive. Longitudinal research could be experimental if there is an intervention. It is also commonly used to study correlations between variables. Although the textbook presents survey research as a distinct research design, we treat surveys primarily as a data collection method that can be used across the quantitative research designs discussed above. Now let's review the major steps in a quantitative research study. To conduct a rigorous quantitative study, researchers first identify a significant and meaningful research problem, often grounded in real-world issues that are worth investigating. Next, they review existing literature to understand prior research and identify gaps, then clearly define the study's purpose, research questions, or hypotheses using measurable and structured language. Finally, they select an appropriate quantitative design, determine sampling and data collection methods, and ensure the study is set up to gather reliable numerical data for analysis. We also have steps for data analysis, results, and discussion, which will be discussed in week 4. Before conducting research, it is important to identify a problem that is meaningful and worth investigating. Researchers should be able to explain why the problem matters and what value the study will provide. Once a significant problem is identified, the key variables can be defined and measured for study. After identifying a research problem, researchers review existing studies to understand what has already been examined. This helps build on prior knowledge, identify gaps in the literature, and justify the need for further research. After reviewing the literature, researchers establish the purpose of the study and define what they want to investigate. In quantitative research, this often involves describing patterns, comparing groups, or examining relationships between variables. Researchers then develop research questions or hypotheses to guide the study. After identifying the purpose of the study, researchers choose the quantitative design that best fits their research question. Different designs are used to examine different types of questions. For example, a correlational design is appropriate when investigating the relationship between variables, such as quality sleep and job performance. Researchers may also develop a hypothesis if they have a predicted outcome. Data collection involves identifying the population of interest, selecting a representative sample, and choosing an appropriate method for gathering data. The text emphasizes obtaining consent, using an appropriate sampling strategy, and collecting enough data to produce reliable quantitative findings. This slide pulls together the main ideas from sampling strategies and the textbook chapters. The key point is that quantitative research relies on numbers to identify patterns and relationships, but those findings still need careful interpretation and a critical eye. Different research designs serve different purposes, so choosing the right one and aligning it with the research question and variables is what leads to stronger conclusions. I hope you enjoyed the lecture for Module 3. In this lecture, I aim to expand on the textbook content by providing additional explanations and examples. If you do not have time to watch the full video, please feel free to review the transcript file. I will see you in Module 4, where we will dive into quantitative data analysis. Please reach out if you have any questions.